స్టూడెంట్స్ బీటెక్ అప్లైడ్ ఫిజిక్స్లో యూనిట్ 1 అండ్ యూనిట్ 2లో ఉండే కొన్ని షార్ట్ ఆన్సర్ క్వశ్చన్స్ ఇక్కడ నేను డిస్కస్ చేద్దాం అనుకుంటున్నా. ఎందుకంటే J/H R22 రెగ్యులేషన్లో అప్లైడ్ ఫిజిక్స్ పార్ట్ 1లో 1 మార్క్ క్వశ్చన్లు ఉంటాయి. దానికి క్వశ్చన్స్ కొంతవరకు యూజ్ అవుతాయనే ఉద్దేశంతో ఈ వీడియో చేస్తున్నా. ఇంకా టాపిక్లోకి వస్తే యూనిట్ 1 యూనిట్ 2 షార్ట్ ఆన్సర్ క్వశ్చన్స్. వెల్కమ్ టు శ్రీ అకాడమీ ఆఫ్ ఫిజిక్స్. ఇప్పుడు మనం యూనిట్ 2 సెమీకండక్టర్ ఫిజిక్స్లోకి వస్తున్నాం. ఓకే, ఇందులో ఫస్ట్ క్వశ్చన్ ఏంటంటే, వాట్ ఆర్ ద మెజారిటీ చార్జ్ క్యారియర్స్ ఇన్ N type అండ్ P type semiconductor? In N type semiconductor, the majority charge carriers are electrons. In P type semiconductors, the majority charge carriers are holes. Okay, what is the necessity of doping impurities? Second question, what is the necessity of doping impurities in pure semiconductors? By doping of impurities in pure semiconductor, its electrical conductivity increases. So whenever you create the defects, there is a change in its physical properties. So in case of semiconductors, when we add impurities are nothing but foreign atoms other than germanium and silicon, which are called impurities. The adding of foreign atoms in pure semiconductor is called doping. So by adding of impurities in a pure semiconductors, what happens? Its electrical conductivity increases. For that purpose, we are adding impurities in pure semiconductors. By adding of impurities, you have two type of semiconductors. One is N type semiconductor and other one is P type semiconductor. Now, next one is define the position of Fermi level in intrinsic and eccentric semiconductors. Intrinsic semiconductor is nothing but pure semiconductor. In that semiconductor, the number of holes in valency band is equal to the number of electrons in conduction band. It means the charge distribution is same in valency band and conduction band. So Fermi level defines the distribution of the charge in valency band and conduction band, just like center of mass. So in case of pure semiconductors, the Fermi level lies middle of the valency band and conduction band. When come to N type semiconductor, we are adding impurities are called donor impurities, which lies nearer to the conduction band. So the distribution of the charge is more in conduction band compared to the valency band. So the Fermi level in case of N type semiconductor, which lies nearer to the conduction band. In case of P type semiconductor, the doping impurity is called acceptor impurity. That impurity level which lies very nearer to the valency band. So the distribution of the charge is more towards valency band compared to conduction band. So the Fermi level shifts towards the valency band side, right? Next question, what is a Hall effect? So in a Hall effect, suppose you are sending the current in x direction, this is current direction, and apply the magnetic field on y direction, then along z direction the voltage is develops. This effect is called Hall effect. So definition lo koddam. According to Hall effect, when a magnetic field is applied perpendicular to the current carrying conductor, a potential difference developed between the points opposite of the conductor. అంటే ఏంటంటే x డైరెక్షన్లో నేను కరెంట్ పంపిస్తూ y డైరెక్షన్లో మ్యాగ్నెటిక్ ఫీల్డ్ అప్లై చేస్తే z డైరెక్షన్లో వోల్టేజ్ అనేది డెవలప్ అవుతుంది. దిస్ ఎఫెక్ట్ ఈజ్ కాల్డ్ హాల్ ఎఫెక్ట్. నెక్స్ట్ క్వశ్చన్ ఏంటంటే, రైట్ ఎనీ టూ అప్లికేషన్స్ ఆఫ్ ద హాల్ ఎఫెక్ట్. ముందు మన హాల్ ఎఫెక్ట్ యూజ్ చేసి యూ కెన్ మెజర్ ద స్ట్రాంగ్ మ్యాగ్నెటిక్ ఫీల్డ్. ఆ తర్వాత మనకి కండక్టివిటీలో ఆర్ ఎలక్ట్రికల్ కండక్టివిటీలో ఆ కండక్టివిటీ అనేది ఏ ఛార్జ్ క్యారియర్స్ వల్ల వస్తుందో మనం చెప్పచ్చు. ఆ తర్వాత ఇచ్చిన సెమీ కండక్టర్ పీ టైపా ఎన్ టైపా క్యాలిక్యులేట్ చేయొచ్చు. నెక్స్ట్ మనం డ్రిఫ్ట్ వెలాసిటీ ఆఫ్ ద ఛార్జ్ క్యారియర్స్ కట్టచ్చు, మొబిలిటీ ఆఫ్ ద ఛార్జ్ క్యారియర్స్ కట్టచ్చు, తర్వాత నెంబర్ ఆఫ్ ఛార్జ్ క్యారియర్స్ పర్ యూనిట్ వాల్యూమ్ క్యాలిక్యులేట్ చేయొచ్చు. ఇట్ హ్యావ్ నెంబర్ ఆఫ్ అప్లికేషన్స్ అండ్ హాల్ ఎఫెక్ట్ దే ఆర్ యూజ్డ్ ఇన్ హాల్ సెన్సార్స్ ఆల్సో. నెక్స్ట్ వన్ ఈజ్ డిఫైన్ డిప్లేషన్ రీజియన్. డిప్లేషన్ రీజియన్ అంటే ఏంటి? సో వెన్ వీ కంబైన్ ద పీ టైప్ అండ్ ఎన్ టైప్ సెమీకండక్టర్, the holes across the junction and electrons across the junction, they cross the junction and cancelled. After some time మనకి ఏమైందమ్మా, దిస్ రీజియన్, ఈ రీజన్ ఉంది చూసారా, దిస్ రీజియన్ మనకి పీ సైడ్ ఏమని అన్ని నెగిటివ్ అయాన్స్లా ఉన్నాయి, పాజిటివ్ వైపు అన్ని పాజిటివ్ అయాన్స్ ఉన్నాయి. So based on this region, there is no exchange of electrons from one region to another region and there is no flow in the PN type semiconductor. Such a type of region is called depletion region or potential barrier. Definition look at them. The region of fixed and opposite charge carriers TV of the junction is called depletion layer. This depletion layer gives the opposition of the flow of free charge carriers. The region of fixed and opposite carriers either side of the junction is called depletion layer. This depletion layer gives opposition to the flow of charge carriers. Diagram neatga vesi ee point ni explain cheste saripotundi. Next one is sketch neatly the band energy diagram. Band energy diagram neatga veyamantanu. ఇక్కడ కాన్సెప్ట్ ఏంటంటే, దిస్ ఈజ్ ద పీ టైప్ సెమీ కండక్టర్. సే దిస్ ఈజ్ ద ఎనర్జీ ఆఫ్ ద valency బ్యాండ్ అండ్ దిస్ ఈజ్ ద కండక్షన్ బ్యాండ్, రైట్? అండ్ ఇన్ కేస్ ఆఫ్ పీ టైప్ సెమీ కండక్టర్ ద ఫెర్మి లెవెల్ లైస్ వెరీ నియర్ టు ద valency బ్యాండ్, రైట్? నౌ this is the n-type semiconductor, right? This is the n-type semiconductor. So in case of n-type semiconductor, the Fermi level, this is the conduction band and this is the valency band. What is this? Fermi level. So the Fermi level which is at the same height in p-n junction diode. So when you combine these two lines, then this diagram it should be called energy diagram, and this region is the depletion region, right? This is the band energy diagram of p-n junction diode. Pine picture ni koncham neat ga veskondi. Next, write the applications of the p-n junction diode. p-n junction diode, the main applications are, first point is it is used as a rectifier. Used as rectifier. What is meant by rectifier? Which converts the AC into DC. Which converts the AC into DC. Second one is it is used as logical switch. Logical switch. So in forward bias, the p-n junction diode is act as a logical switch on, and reverse bias, the p-n junction diode is act as a logical switch off. మిగతా పాయింట్స్ మీరు చూసుకోండి, దీని ప్రకారం మనం రాసుకుంటే దీస్ 2 points are very important. Okay. Next one is, what is the Zener diode? So Zener diode is a heavily doped silicon p-n junction diode. So the doping concentration is more in p-n junction diode, then it should be act as a Zener diode. So whenever the doping concentration is more, its depletion layer is very thin and we get the sharp breakdown in reverse bias. Zener diode is always operated in reverse bias. In reverse bias, Zener diode is act as a voltage regulator. So Zener diode is always operated in reverse bias. In reverse bias, Zener diode is act as a voltage regulator. The symbol of Zener diode is ఇలాగ ఉంటుందమ్మా. ఈ ముందునేమోని Z ఉంటుంది, and this is the anode and this is the cathode, P and N. This is the symbol of the Zener diode. Next, what is LED and write about its device material. So LED is nothing but light emitting diode, and it is a specially designed PN junction diode, and it is operated in forward bias. Zener diode is operated in reverse bias, and LED is operated in forward bias. So when you prepare, when you choose the material of LED, it must have these 3 points. First point is you must have suitable energy gap. You must have an energy gap with suitable energy gap suitable for radiation, and P and N regions must be low resistivity, and band gap tunability with suitable dopants from direct band gap to indirect band gap and vice versa. So what is meant by this tunability? Actually, the wavelength lambda is equal to 12,400 by energy gap in electron volts. The answer directly you are getting in angstroms. So from this equation it is clear that the emitted wavelength from the LED source is depends upon energy gap. Whenever the energy gap is changes, accordingly the wavelength value is also changes. So for changing of this energy gap, the emitted wavelength value is also changes. So whenever the energy gap is changes, or we are tuning the energy gap, accordingly the emitted wavelength is also changes. Right. What is the principle of LED? So the principle of LED is always operated in forward bias, first point. And when you are operated in forward bias, due to the recombination of electrons and holes which emits the light when given energy by the principle of electroluminescence. This is a very important point. What is solar cell? Next question. Solar cell or battery or photovoltaic cell is basically a PN junction diode which converts the solar energy into electrical energy. So it is also called solar energy converts, and photodiode is always operated in zero bias voltage. We are not applying any biasing for the solar cell. So solar cell which converts the solar energy into electrical energy. Then explain the principle of pin diode. So in case of pin diode, has a broad eccentric semiconductor layer between the P plus and N plus region. For example, this is highly doped P plus region, and this is a highly doped N plus region. In between you have intrinsic semiconductor. Now the light is allowed to incident on this region at by applying of reverse bias. What is meant by reverse bias? P is connected to low potential, N is connected to high potential. So this diode you are connected in reverse bias, and this voltage you are making to increase. At a particular situation, this entire region, it should be act as a depletion region. When at the situation when light is incident on this depletion region, which emits the electron and hole pairs, and they are moving towards P and N, we are observing some current in the circuit. right? This is the working of pin diode. So pin diode has a broad intrinsic semiconductor layer between p plus and n plus regions. The incident photon produces free electron and hole pairs in the depletion intrinsic region, where most of the incident light is observed. High electric field in the depletion region causes free charge carriers separate and move across the base junction. This gives rise to current flow in the external circuit. Explain fill factor. Next question. Explain fill factor. So when we draw a curve in solar cell, voltage on x-axis, current in y-axis, the curve is appears like this. This point is called open circuit voltage and this point is called saturation current and the short circuited current, right? So in this curve you can put the different squares. This is one rectangle. The area I into V. So what is the formula for power? Power is equal to V into I. So the area of this square or this rectangle, it represents power. So you can write a different type of squares like this, right? So you have different areas as well as you have different powers. But at a particular situation, the power should be maximum. So that square by inserting of a particular square in a VI curve, you will get the maximum power. That concept, it should be called fill factor. So fill factor measures the squareness of the VI curve, right? How to define the fill factor? Fill factor is equal to the area of the square by the area of the curve, right? Let us say this point, at this point the power is maximum, right? So here this is called maximum voltage and this point is called maximum current. So at this maximum voltage and at this maximum current, you will get the solar cell, it should be maintains the maximum power, right? So the solar cell, you must operate in this voltage and current. Okay, now what is the square area of the square? The area of the square is nothing but length into breadth. What is length? Vm and Im, right? What is the area of the curve? VOC into IS. So this is the formula for fill factor. But this area is more compared to this one. So this value is always less than 1. Fill factor value always less than 1. Next, list out any two applications of the pin diode. Pin diode used as a high voltage rectifier. Pin diode is used as a radio frequency switch. Pin diode is used as a photo detector. సో థ్యాంక్ యూ. అండ్ ఈ వీడియో మీకు బాగా యూజ్ అయింది అనుకుంటాను. కాబట్టి నా ఛానల్ని సబ్స్క్రైబ్ చేసుకోండి. ఇలాంటి వీడియోస్ ఇంకా మీకు యూస్ఫుల్ అయినవి చాలా పెట్టగలుగుతాను. ఓకేనా? థ్యాంక్ యూ.